If you're constantly getting redundant constraint errors and you're tired of hunting down the one causing the mess, just check the Auto Remove Redundant Constraints box in the settings. I know the FreeCAD purists are probably fuming right now. By checking this, you're letting the software delete constraints automatically, which can sometimes lead to a messy sketch that's a nightmare to fix later. Personally, I've rarely had any issues. Stop wasting time searching for that tiny eye icon in the tree view. You can instantly hide or show any object, whether it's a body, a sketch, or a specific feature, simply by pressing the spacebar. It works both ways. Hit space to hide, hit space to reveal. Once you get used to this shortcut, you'll never go back to manual clicking. Since version 1.1, you can generate faces from a sketch by checking the Make Internals box and perform extrusions on them. But you've probably been in a situation where you missed a few faces or you just want to add more later. For example, on this masterpiece, I want to add the eyes and the teeth. But when I double-click on the pad tool, you can see there's no option to add more faces. To fix this, go to the Pads Data tab, look for Sketch-Based, and click on Profile. In the window that pops up, click Clear. Then in the viewport, hold down Ctrl and select the faces you want and click OK. Now, when you make the pad visible again, nothing seems to change, don't worry. Just right-click on it, hit Recompute, and your model is good to go. Well, except for this guy. This thing belongs in the trash. You can actually create a pie menu for any tool in any workbench. This tool is available from the add-on manager, and as you can see here, it's a huge time saver during modeling. It also adds a modern graphical overlay for your operations. For example, it gives you the ability to tweak values directly with your scroll wheel. The customization options are massive. You can change almost everything. You can choose which workbench triggers a specific pie menu, create different profiles, add or remove tools, and even rearrange the entire layout. It's truly a massive boost for your productivity, and it saves you an incredible amount of time. To install this tool, go to the Tools menu and select the Add-on Manager. Then type Pie Menu in the search bar and install it. Once installed, you'll need to restart. To customize your menu settings, head over to the Accessories menu. This add-on is truly a game changer and well worth the detour. Take a look at the sketch icon. You'll see small overlays that give you info about your sketch. For example, on this first one, there's a yellow X. This means your sketch is under constraint, so it can basically wander around the viewport. To make that X disappear, your sketch needs to turn fully green. The second icon you might see is a purple circle with 2 white dots. This means your sketch isn't attached to any geometry, no plane, no face. To fix this, go to the Sketch's Data Properties. Under the Attachment section, you need to select a plane or a face. Since we don't have a face here, we're going to choose the XY plane and click OK. After that, the symbol should disappear. You'll almost never see this happen in part design, but it pops up quite a bit in the part workbench. If your sketch doesn't have any icons at all, then everything is perfect. It's fully constrained and properly positioned. To respond to Xana, yes, you can have a grid with snapping, but it's not the default behavior. When you've created a sketch, you need to go into the Sketch settings, the menu with the wrench and screwdriver icon, and check the boxes for Display Grid and Snap to Grid. After that, you can use any drawing tool and they will automatically snap to the grid. You can also change the grid size. You'll just need to zoom out a little bit to see the new grid layout. When drawing in the Sketcher, you can use hidden shortcuts to speed up your workflow. For example, you can draw a rectangle with rounded corners simply by pressing the U key while drawing, and even add an offset by pressing J. By the end of your stroke, you will have a fully constrained shape without having to manually use dimension, fillet, or offset tools. It's a massive time saver. If you want to make a spline tangent to a circle, you can't just select the spline and the circle and hit the tangent constraint. It simply won't work. To make it happen, you have to select one of the spline's endpoints and then the circle. Apply the tangent constraint now and your spline will perfectly align with the circle. This method also works if you want to make 2 splines tangent to each other. By combining these 2 techniques, you can make a B-spline perfectly tangent at any specific point, not just at the endpoints. Here's a pro tip for complex models. When you need to apply a fillet to multiple edges, don't waste time holding the Control key. One misclick and you lose your entire selection. Instead, launch the Fillet tool first. This activates a selection mode where you can simply click each edge one by one without holding any keys. It's safer, faster, and much less frustrating. When you create a fillet or a chamfer, it automatically propagates to all tangent adjacent edges. The thing is, in FreeCAD's fillet options, there's no way to stop this behavior, unlike in Fusion or Plasticity, where you can just toggle it off. Here we have to be smarter than the solver and do it ourselves. You need to create a circular arc matching the fillet radius on a face or a plane tangent to the edge you want to fillet. If it's a simple shape like this one, a basic pocket operation is enough. But for more complex objects, like this one here, you can use a subtractive pipe and manually select the exact edges where you want the propagation to happen. It's a bit time consuming, but for now it's the only way to stop the propagation. Did you know you can actually create variable fillets? Unfortunately, the tool isn't available in part design, so we have to switch over to the part workbench. Here I'm going to create a fillet at the end that starts with the current radius and tapers down to 0. To do this, start by selecting the edge, then launch the fillet tool. In the task menu, change the type to variable. I'll set the first value to 3 mm and the second to 0, so it ends in a sharp point. Hit OK, and there you go, a perfect variable fillet. Now the downside of this workflow is that by leaving part design for the part workbench, you're stuck with a separate object. If you want to continue in part design, you will have to create a new body and manually import the fillet result as a base object to build your next operations around it. With this macro, you can send your models directly to your favorite slicer without having to export the file yourself. The macro handles everything and exports it in 3MF format. All you have to do is provide the installation path of your slicer and choose your desired mesh quality. Then you're just one click away from your print settings. To install it, head over to the add-on manager, type 3D in the search bar, and install 3D printer workflow. You can also install the PCBWay macro, which directly uploads your files to their website for manufacturing. They are the sponsors of today's video and simply leaders in PCB manufacturing, 3D printing, and CNC machining. Once your file is uploaded, you can choose from a wide range of detailed options and get an instant quote. I've tested their services multiple times, specifically for this bike chainring, and the result was amazing. The quality was flawless, the tolerances were spot on, and all that for a great price, even for small quantities. Don't hesitate to take advantage of their current offers. You can get a $5 discount on your first order. They really are the perfect partner for your prototyping needs and even for mass production. A huge thank you to PCBWay for sponsoring this video. Answering Magnus' question. Yes, you can actually model the threads directly when creating a hole. When you launch the hole function, you first need to choose a standard. I'll go with isometric regular, but pick whatever fits your needs. Then select your hole size. Now if you stop there, the threads won't show up. To actually see them, scroll down to the thread type option and set it to modeled. You then have several options to customize your thread. You can choose the tolerance class, the direction, right hand or left hand, the depth, and even a clearance. In this case, I want a through hole, but with threads only on the first 10 mm. So I'll set the thread depth to 10 mm and then change the depth type above to through all. Once created, you can clearly see that the thread has been generated perfectly inside the hole. If you're watching this from the future and using version 1.2, you now have the option to use a thread texture instead of full geometry. To do this, simply uncheck Modeled before creating the hole. You'll see the texture appear directly inside the hole in the viewport, just like in Fusion. If you've ever used FreeCAD to model complex parts, you know that fillets can be unstable operations and often lead to recomputation errors. For example, here I have a solid with 2 fillets and I want to place a hole in the center. Instead of selecting the face generated between the 2 fillets, I can go back in time to my pad operation and select that original, much more stable face. I create my sketch on it, and as you can see, the pocket works perfectly and no longer depends on the geometry created by the fillets. Always try to create your sketches on stable faces to avoid broken models. Did you know you can actually change the order of your operations in the tree view? For example, I made this hole after my mirror operation, but now I realize it should have been mirrored too. Instead of deleting it, just right-click the feature and select Move Feature After. In the window that pops up, just select the last operation before the mirror and click OK. Then simply make the mirror visible again and you'll see that the hole has been perfectly included in the symmetry. However, be careful with this tool. If you've attached your sketch to a face created after the mirror, the operation will fail. This is why you must always choose a stable sketch plane created before the mirror, just like we discussed earlier. By attaching your sketch to the first pad, you're going back to a clean base with no extra dependencies. Always keep the creation order in mind to avoid errors. In FreeCAD, logic is your best friend. Another alternative to add a feature at a specific point in the tree view is the Set Tip tool. It's basically the equivalent of moving the playhead in Fusion's timeline. It tells FreeCAD to build everything starting from this feature. If we take the example of our hole again, right-click on the operation just before the mirror and select Set Tip. Now any new feature you create will be inserted right there between that operation and the mirror. You can then create your sketch on the pad, make your pocket, and it will be perfectly integrated into the history. If you look at the tree view, you can see that the pocket was created before the mirror. Now when we make the symmetry visible again, the hole is perfectly included in the operation. But be careful, if you want to add a fillet to an edge now, it won't work because the tip is still set before the mirror. To continue your design normally, you must right-click on the very last operation of your tree and select Set Tip again to get back to the present. And now you can comfortably create your fillet and continue with your operations. The last tool to help you navigate the tree view is the Suppress tool. It allows you to mute an operation without having to delete it and mess up your entire model. For example, by suppressing this pocket and recomputing the object, you can see it no longer appears after the mirror. This action is reversible. If you ever need that operation again, you can just unsuppress it and it will reappear instantly after a recompute. When working on assemblies, you've probably faced reconstruction errors or constraints that just snap for no reason. By default, FreeCAD generates LCS automatically when you constrain parts, but if a part is modified, everything often breaks. I highly recommend creating your own LCS manually within your parts first, and then using those to constrain your assembly. This workflow is way more robust, even if it is a bit more time-consuming. This effectively counters topological naming errors by anchoring your constraints to more robust objects. Currently, FreeCAD doesn't have a dedicated section analysis tool. However, you can easily adjust a part's transparency in the view properties, which is great for visualizing internal components like these screws. Another option is the clipping view, which gives you a section-like view, though the internal faces remain hollow. The good news is that Greg Jaskiewicz is working on a much better version of the section analysis tool that should be released soon. Definitely keep an eye on that. To find out the weight of your part, you currently need to use a macro. I recommend FC-info, which you can easily install from the add-on manager. Once launched, it gives you a ton of data about your model, but what we're interested in is the weight. You can select a standard material, I'll pick aluminum here, or even input a custom density if you are working with a specific material. Then the macro will return the exact weight. If you are using FreeCAD 1.2 dev version, the workflow feels a lot more like Fusion. You can simply right-click on the body, assign your desired material, and you'll find a new icon in the toolbar that gives you the weight instantly. It's much more intuitive and you don't even need to use a macro anymore. Since FreeCAD 1.0, you can now create multiple solids within a single body in part design. However, you might want to separate them later, for example, if you only need one specific solid for an assembly or to export it for 3D printing. To do this, you need to switch to the part workbench. With your body selected, use the Explode Compound tool. In the tree view, a new folder will appear with your solids clearly separated. You can now move them freely or start new operations on them. Even if you modify the original base file, everything remains fully parametric. If you want to create a pattern along a path, you can't do it directly within part design. For example, to create this shape, I had to create a base body and a second one to act as a cutter. It's vital here to place the cutter or the solid you want to array exactly on the axis origin, as this position is what the path array uses as a reference. If it's offset from the origin, every single repetition will be offset from the path. Next, you need to switch to the draft workbench. First, select the solid you want to repeat, then select the path you want to repeat it along while maintaining control. Finally, look for the Path Array Link tool. To change the number of occurrences or the spacing, go to the data properties of the path array. You have quite a few options here, but let's keep it simple and just change the count to 16. To continue working in part design, double-click on your main body in the tree view to make sure it's active again. Now we need to bring that path array into our body. To do that, we'll use the Subshape Binder tool. Simply select the path array, then trigger the Subshape Binder. You should see it appear as a transparent yellow shape in the viewport. Now hide the original path array, select the body and the binder while holding Control, and trigger the Boolean operation tool. In the task menu, just set it to cut and it's done. The beauty of this workflow is that everything remains parametric. You can change the number of occurrences in the path array's data properties, and the model will update instantly. You can even change the diameter of the base cylinder and everything follows. You can even keep adding more operations on top of it. You can actually create a custom toolbar with tools from other workbenches. This saves you from constantly jumping back and forth between workbenches, like we just did in the previous example. To do this, simply right-click on the toolbar and select Customize. In the window that pops up, go to the Toolbars tab and click New. Once you've named your menu, you can easily add different tools using the search bar. Once you've found the tool, just click the blue arrow to add it. You can add as many tools as you like from any workbench. For instance, I also added the compound tool to handle exploded views like we saw earlier. Once you're done, your selected tools will appear in the toolbar for instant, easy access. When working on large assemblies, your viewport might feel laggy and not very smooth. By checking one simple box, you can greatly improve the situation. To do this, go to Edit, then Preferences and select Display. In the 3D View tab, check the Use OpenGL VBO box. When you return to your scene, you should see your FPS increase significantly. If you want a more modern look, you can install a theme that will truly overhaul the interface. I personally recommend the Open theme by Obelisk79, which I find very good. But feel free to explore the add-on manager or even create your own theme if you're feeling adventurous. And I have one final and maybe the most important tip to end this video: the brand new
element of surprise!